Mechanical property of the material. So we discuss first mechanical property of the metals or materials. Okay, because we're going to design any component, then we deal with the metals. Okay, so materials is everything like your tree, your wood, your salt, your soil, all things is material. But in the strength of material, we deal with the metals. So we're going to discuss the mechanical property of the metals. Okay, this is our third unit. Why we choose this as a starting unit? Because before going to design any component or product, we decide the metal or material for that. Okay, we decide the metal or material for that. So on which basis we going to select the material, that is the mechanical property of the metals. So first we study about the mechanical property of the metals. Okay, so what are the mechanical property? So we discuss like that. Our mechanical property is like strength, elasticity, stiffness, plasticity, malleability, ductility, brittleness, hardness, toughness, fatigue, and creep. These are the 11 properties which we are going to discuss in today's lecture. Okay, so students, all remaining students, please join the lecture. ऐसे आप लोग ठीक है कल आए थे हाँ कल आए थे बारिश डेली लगती है Okay, this is the agenda for this topic. First, type of mechanical property. Okay, so today we trying to finish the mechanical property. Okay, so mechanical properties we finish means today we are going to finish the first point mechanical property. After that, mechanical test of the metals. So what are the mechanical tests we conduct to measure the mechanical property, like the elasticity, ductility, hardness? These are the test, different type of test where we going to measure the mechanical properties. Okay, like how much strength in the material, what is the hardness of the material, how much elastic of the material, what is the plasticity index for the material. Okay, so these are the different properties we are going to test. Okay, so that we can go in the detailed hardness test and impact test. Hardness test and impact test. Okay, so types of mechanical property defined as those property which completely define its behavior. Defined as those property which completely define its behavior under action of external load or force. Okay, so whatever the property is there, this property is developed where external force or load apply on the component or the material. Okay, so when we going to test the material, we have to apply the external force or external load of the component, so we can conduct the test. For conducting the test we need to the for conducting the test we need to apply the different type of loads or force on the component to check the different properties. Okay, so next things, those properties which associated with its ability to resist the failure. Okay, to resist the failure means, first I tell you what is the difference between failure and breaking or fracture. Okay, there is the definition of failure is the component or model is not performing its desired application. Listen carefully. What is the failure? The failure is the component or equipment or product is not is not perform its application what it's made. Okay, and what is the fracture? Fracture is nothing but breaking the component is broke down. Okay, so a product which is fractured or breakdown, it doesn't mean it fail. Failure means whatever the application equipment equipment or product made for, if the product or equipment is not performing that application, it meaning it's fail. Okay, and what is the meaning of fracture? Fracture is nothing but it is the break the component. Okay, so I tell you example where failure, sorry, fracture is not a failure. Okay, like our blackboard chalk. Okay, what is the usage, what is the application of the chalk? To properly write on the blackboard. Okay, but if the chalk is breakdown fractured, it is the meaning chalk is fail? No, many of the time we break the chalk and write on the blackboard. Okay, but if chalk is not properly right on the blackboard, that is the failure of the chalk. That is the failure of the chalk. Okay. So if the component or equipment is not performing their application which for which they are made, that is the meaning of the failure. Okay. Like if you purchase a bike and your bike is not properly run on the road, that is the failure of your bike. Okay, so those property which associated with its ability to resist the failure, its behavior under the action of external force. So, knowledge of the mechanical properties essential for the engineers in selecting the suitable material for the various application. For the various application. So, it means, see, essential for the engineer in selecting the suitable material for the various application. That's the reason why we study this unit first, because this unit is our third unit and we start it like a first unit. Okay, because before we going to design a component or we select the material for that component, we need to a deep knowledge or a basic knowledge regarding the mechanical property of the metals. Okay, after that we can select the material or metal for different application components. Okay, so here the mechanical property, strength. What is the strength? Ability to withstand or support external force or load without rupture. Rupture is nothing but it is a causes of failure. Means rupture means without any cracking or damage. Okay, that is we call the rupture. Ability to withstand or support external force or load without any rupture means whatever the external force supply on the component, maximum force supply on the component by which your product or component is not break out, cracked out, or broken. Okay, so that is the definition of the strength. So whatever in other hand we can say strength, the ability of a material to resist its failure under the action of load is called as the strength of the material. Okay, listen once again. The ability of a material to resist its failure under the action of load or external force is called as strength of material. Okay, so you can use this definition as a strength of material. Okay, what is the strength of material? So strength of material means the ability of a material to resist the failure under the action of load is called strength of material. Material should have sufficient strong when subjected to tension, compression, bending, shearing, and torsion. Okay, so what are these things? Subjected to tension means tensile force when the component under the tensile force, compressive force, bending force, okay, and shearing force and torsion. Okay, so these are the type of load, we can say these are the different type of load: tensile load, okay, compressive load or compressive force, and bending force. What are the bending force? Means the force which is act on a body and tend to bend the component. Okay, the force called bending force which is apply on the component or uh, product and is tend to bend the material or bend the component. That is our bending force. All the force definition is like that. Okay, the force apply on the component which is tend to stretch the material or stretch the component, that these forces called the tensile force or tensile force. The force which is tend to compress the material or product, is called the compressive force. A force a force or number of force acting on a body and the force tend to shear the material, that is called the shearing force. And similarly force which is trying to twist the component, that is called the torsional force. Okay, So this is about the strength. What is the strength? Ability of the material to resist the failure under the action of external force or loads. That is the strength. Okay, so there is any doubt for the definition of the strength? Any students? If you have not understand what is the strength, then you can call me or you can ask your question. Okay, so I think there is no question. So our second property is hardness. So what is the hardness? Hardness, the ability of a material to resist wear, scratching, abrasion, cutting, or indentation, penetration by the harder body. It's called hardness. Okay, or we can say ability to resist the deformation by the abrasion, intentions, or penetration and scratching by harder body. That is called the hardness. Okay, so what is ductility? Ductility, ability to undergo applicable plastic deformation before the rupture. Ability to undergo applicable plastic deformation before the rupture. Okay, what is the meaning of that? What is the meaning of that? The meaning of that, we apply the force on any component, and whatever the plastic deformation happen before the fracture or rupture, before the fracture or rupture, it's called ductility. Okay, okay, so what we can say in other word, ductility, it is the property of a material due to which it can be drawn into thin wires. Okay, what do you say? It is the property of material due to which it can be drawn into thin wire and application of tensile force. Okay, whatever the application you like, definition you like, you can write. There is no problem for that. Okay, so ductility, it is the property of the material by which material or metal can drawn into thin wire. That is the ductility. Okay, so next is brittleness. So what is the brittleness? Ability to failure when deformed, ability to fracture when deformed. So brittle material is that type of material which is not resist any deformation, which is not resist any deformation. So the harder material, we can, they are also brittle material, because like our glass is harder material. Okay, so when we trying to apply deformation in the glass, then what happen? The glass is convert into the pieces. So that is the brittleness. Okay, like our coal, coal is also a brittle material. When we apply the external force, they are not deformed, they just broke down, convert into the broke down into the pieces. So that is the that is the brittleness. Okay, so what we can say in other word, it is the property of material due to which it is the property of the material due to which it can be directly broken without any further deformation. Without any further deformation. In such case, material may fail without any period warning. Cast iron, concrete, glass, stone, clay product, bricks are the example of brittle material. In shock, lack of ductility in call brittleness. Okay, so what happened? The brittle material have good compressive strength. What we can say? Compressive strength. Compressive strength, the resistance of the component or product against the compressive force. Against the compressive force. So we can say that the brittle materials have a good compressive strength, like uh, all the all the machine base, whatever it is, lathe machine or shaper machine, whatever the different type machine, the base of the machine is made by the gray cast iron only, because gray cast iron has, because more compressive strength in comparison to others. Okay, so what is the toughness? Okay, now you can see the toughness and strength. Toughness and strength definition is much similar. Okay, so ability to absorb maximum energy up to fracture. What is that? Toughness is the ability to absorb maximum energy up to failure. Must be strong and ductile to be tough. Okay. So ability to withstand impact value increase when temperature is increased. Okay. So, what is the toughness? So, in your age, somebody say that like that this boy is very tough. This is a tough guy. Okay, like that. So, what is the meaning of tough guys or tough boy? So, the meaning is that they can resist the more critical situation comparative to others. The boy which is tough is resist more critical situation compared to others. Okay. Similarly, the tough material toughness is ability to absorb maximum energy. Maximum, what is the meaning of energy? Energy is the form of forces. Different type of forces apply on the component, and if the material or component resist that different type of forces, then there is more tough. Okay, whatever the different, there is compressive force, tensile force, and because some material is have good compressive capacity, but they broke down in the tensile. Okay, some force had good tensile capacity, but they broke down in the impact loading. Okay, so whatever the materials which is resist all the different type of forces, that is the more tough. Okay, in other word, what we can say, what is the toughness? Okay, the amount of shock energy, the amount of shock energy absorbed by the material before its failure take a place, it is called the toughness. Whatever the different type of forces apply on the component, and the components with the different different resistive capacity against the different type of load application, that is the toughness. Elasticity, what is the elasticity? Ability to retain its original shape and size after removal the load. So what is the elasticity? Elasticity is nothing but it is the ability to retain its original position when we remove the external load. Okay, that is the elasticity. Means what happened, we apply a force on the component and some deformation is shown, but when we remove the that load, the material original position, that is the elasticity. And we also, there is a constant called the elasticity constant E. We also called it Young models. Okay, so Young modulus is nothing but constant of elasticity. Okay, so what we can say, that elasticity is the ability of material to regain its original shape and size. Regain its original shape and size. Okay, that is the elasticity. Elasticity is the property of the material by which it's regain its original position after removal of the force. Okay, plasticity. What is the plasticity? Plasticity, plasticity is the property of the material. Plasticity is the property of the material by which material undergoes the permanent deformation. After the elastic limit, plasticity is generated. After the elastic limit, plastic deformation is generated. Means we apply the load on the component, and when it's shown some deformation, and when we remove the force, the material it doesn't gain its original position. Doesn't gain its original position. That is called the plasticity. And what is the resilience? What is the resilience? Ability to absorb energy when it's is elastic deformation. Okay, what is the resilience? Okay, what is the resilience? Resilience is nothing but it is the uh, energy absorption by the material when we deform under the elastic limit. When we deform under the elastic limit. Okay, malleability, ability to deform into thin sheet by rolling or hammering without fracture. Okay, so which material is have more, means like your steel, the other steel sheet, aluminum sheet, and silver sheet, and the gold sheet. Okay, copper. So they are easily convert into the thin plate. Okay, and they are have the malleability as well as ductility, because we can see the. Okay, which material have ductility That material also have the property of malleability, means which material we convert into wire, we can easily convert it into the thin plate. Okay. Next is machinability. What is the machinability? Means it is the property of a material. We can easily machine them. Means we can make a hole on them. We can make thread on them. We can make turning on them, learning on them. What are the machining operation we can easily perform on which material, that is the more machinability, that is have more machinability. Okay. Weldability. What is the welding? It is the property of welding. Okay. So if by welding we can easily join two materials, if by building we can easily join the two material, so that is have more weldability, we can welding. Okay. Costability. What is the costability? It is the property of costing, like more costability have aluminum, silver, gold, and paraffin, like a moon. Okay. So these are the have more costability. Okay. So these are the mechanical property we study here, and here you can see the different type of test.